Today's lesson is IC32. This is going to be the first half of the lesson to get you started, and then we'll finish it up tomorrow. To start, we're going to be proving that lines are parallel. So in order to do that, you need to understand what a corresponding angle, alternate interior, alternate exterior, and consecutive interior angles are. So converses are where you do the opposite. So before we had lines parallel, so angles were congruent. What we're going to do now is angles are congruent or supplementary, therefore the lines are parallel. So the corresponding angle is converse, and this is very important. Converse versus postulate and theorem are totally different ideas. So whenever you are now doing any proof with corresponding angles, any type of these angles, you have to make sure if you are using a postulate and theorem, because if you don't, I'll dock you. Or if you don't put converse, I'll dock you, because I don't have the ability to understand what you're trying to say anymore. So this is really important, and you will be marked down if you do not use these correctly. So corresponding angles, converses, corresponding angles are congruent. I'm just going to use the congruent symbol. Then the lines are parallel. Alternate angles, converse. Alternate angles are congruent. So if the alternate angles are congruent, the lines are parallel. And if you don't remember what the parallel symbol is, it's just two L's right next to each other. Alternate exterior angles, they are congruent. So if there are two angles, those are congruent as well. Then the lines are parallel. Consecutive interior angles are the only ones that are not congruent. So if these are supplementary, then the lines are parallel. If you need to prove lines that are parallel, you need to use one of these four converses. And converses, once again, is proving lines parallel. That's really important. So based on what we just did, we're going to talk about these angles. I'm going to use different color sets for each one, and then I'll highlight up above for color coding, just to let you know. So the first one we have here is 2 and 6. So angles 2 and 6 are a type of angles. They are on the same transversal, so the transversal is transversal M, so that's on the line that they're on. The two lines that are parallel possibly are K and G. 2 and 6 are alternate exterior angles. So this is alternate exterior angles converse. And the parallel lines is K and G. So K is parallel to G. And so like I said, these are an example of alternate exterior angles. So I'm going to come up here and I'm going to highlight alternate exterior angles. So when you guys come back and you look at this, you can say, hey, there's color coding. So the next one I have is 1 and 5. So 1 and 5. 1 is here, 5 is here. They are located on line K. So this is the transversal K, which means we're looking at the lines being parallel of M and P. So M is parallel to P. These are corresponding angles, so this is the corresponding angles converse. Once again, if you don't put converse, you are wrong. Next that we got is 3 and 7. Oops, I forgot to highlight up above. Orange. Corresponding angles converse up above. Apologize. So 3 and 7. 3 and 7 are right here. So 3 and 7 are on the interior. So we have either consecutive interior or alternate interior. They're on the opposite side, so they're alternate interior. So this is going to be the alternate interior angles converse. They are on the transversal of P, line P, so that means K and G are parallel. Last one we have, so I'm highlighting just up here, is obviously the last example that we need, which is consecutive interior angles. So I'm going to do this one in blue. we're looking at this angle here, and we're looking at this angle here. Those two angles, let me move those back up, I apologize. They're on the same side. They are on transversal G, which means they're between the parallel lines of M and P. The reason why I'm saying they're in parallel is because we say that they add up to be 180, which is the definition of supplementary. So M is parallel to P. This is the consecutive interior angles converse. So up above, I'm going to highlight that in blue. Once again, color coding is really important for me visually, just as I'm doing certain new things. It just activates my brain better, so if you don't want to color code, you don't have to, but that way you know examples down here of what angles you're looking at to be congruent to make lines parallel. So once again, lines are not parallel first. Angles are either congruent or supplementary. Therefore, lines are parallel. All right. So what I'm going to do is I'm going to jump down to the proofs now. We're going to start with this first proof. I will highlight as much as I can. So we have two sets of lines. You have to really pay attention to what information is given to you. So with this, we have line M and N. Line M and N are parallel. So I'm going to underline this here. M and N are parallel. 4 and 6 are congruent. So I'm going to do some highlighting here just so I don't lose what I'm doing. 4 and 6 are congruent. And I need to prove that lines K and L are parallel. In order to do that, I need to get a set of angles on transversal M or transversal N to be congruent. You can do either one, because I'm already looking at this and saying, hey, I could do this proof two different ways. I can use 2 or I can use 3. If I use 3, that would be corresponding angles to get 6 to 3. And then I can use, I'm so sorry. 6 to 3 corresponding angles postulate in order to say that 6 and 3 are congruent. And then I can use trans property to say that 4 and 3 are congruent. Nope, don't want to do that. Cannot do that. Let's try this again. 4 to 3, because I need to be on this transversal. 4 is congruent to 3 by alternate interior angles. Or I can use 4 to 2. Nope, can't use 4 to 2. Pomeroy, what are you doing? I can't use lines K and L, so I got to be on either this transversal or this transversal. I can use 4 to 3 for alternate interior angles, or I can use 6 to 2 for alternate interior angles. Like, I could use angles 2 or 3. They're either alternate interior angles on line L or alternate interior angles on line K. Pomeroy's got it now. Not enough coffee yet this morning. So, depending on which one you want to choose, but I'm going to start with my first line. Line M is parallel to line N. That's a given. And then, like I said, angle 4 is congruent to angle 6. Given. Now, from here, I can, like I said, I can go 4 to 3 and get 3 to 6. Or I can go 2 to 6, because it's on this transversal of this parallel line, that are congruent in order to get 4 to 2. Your choice, either way, it's going to be the same thing. So, 3, I'm going to choose to go 6 to 2, because I really want to use angle 6 to 2. Angle 6 is congruent to angle 2. This is alternate interior angles theorem. So important to have that, and here's the reason why. Excuse me. And then 4, I'm going to get 4 to 6, 6 to 2. 4 is congruent to 6, 6 is congruent to 2. I'm going to just say angle 4 is congruent to angle 2. And so what I'm going to do really quick is I'm going to highlight these in a different color, and it's nothing based up above, just so I can say, hey, I know what type of angles they are. So this one here is now congruent to here. And I said I had to be on either transversal M or transversal N 4 and 2 are on the same line of M, so lines L and K are now parallel. So this is the transitive property. Okay. But since these are corresponding angles, line 5, I can state that line K is parallel to line L. And this is why those theorems and postulate versus converses are so important. These are corresponding angles, but since I'm proving lines parallel, corresponding angles, I can't use postulate because that would be saying angles are congruent. I have to make sure I use the word converse, because converse is when you prove lines parallel. Once again, I'm going to say this again. Theorem and postulate is when you are saying angles are congruent. Converse is when you're proving lines parallel. So we're going to do the next proof. So once again, I'm going to highlight what I know, and it's not about the colors that you choose. It's about whatever things you can do to help visualize for you, and obviously I need more coffee this morning. So line K and L are parallel. So this angle, or this line is parallel to this line. See, that's how far out of it I am. Gosh darn it. And then 2 and 6 are 2 and 3, Pomeroy. 2 and 3. 2 and 3 are congruent. I promise. I know what I'm doing. So I'm now going to prove M and N are parallel, which means I got to get angles on K or L to be congruent. And now, since I could have used 2 or 3 before, I'm going to use the opposite of 6 or 4. It's your choice of what you want to use. It's kind of the same proof now that I look at it. Alternate interior angles. You know what? We'll go here. We're going to go to 4. So, number 1. Line K is parallel to line L. That is given. And then number 2, angle 2 is congruent to angle 3. This is also given. What we're going to do now is I'm going to go, since this is my parallel lines, K and L are parallel, I'm going to use this transversal. I'm going to state that angle 2 and angle 4 are congruent. Angle 2 is congruent to angle 4. These are corresponding angles. By the way, this is a postulate based on our notes. It's also a theorem. But it is definitely more so a postulate in our theorem. You know, we proved it. It's a theorem. I don't care. Just make sure you have one of those. Excuse the bell. So now I've said 2 and 4 are congruent by corresponding angles. So 2 is congruent to 3, 2 is congruent to 4. So my next step is angle 3 is congruent to angle 4. And the reason why I want those is because they're on that transversal of K, and I wanted it to be on K or L. This is the transitive property. Okay. So now that I know those two are congruent, I'm going to throw some that orange back in there. So now I know that 4 is congruent to 3. They are alternate interior angles. So I am not saying these angles are congruent. I want to make my lines parallel. So I have line M is parallel to line N. And this would be alternate interior angles converse. Once again, it's converse because I am proving lines parallel. So it is converse. If you are not clear, and you'll start to find that I definitely like using corresponding angles and alternate interior angles more than I like using any other ones, if I can. I like to always end on corresponding angles converse if I could. That's why I was looking at this. I'm like, how can I do it different without thinking the way I want to? Proofs, once again, are however you want to do them, as long as your statements to get there are true. And when I was going through the homework 31, there was a lot of you that did lots of different things, which was really cool to see. And it wasn't how I was thinking. So feedback on those take a lot of time. I got through as much as I could yesterday before shutting down, changing my ideas. So just letting you know, make sure that you pick how you want to do your proof. Like, it's up to you. So I'm going to turn it over. And I am going to do one of these on the back. I'm going to do 3 because it has to do with bisecting. And we'll do this one, and then you guys will have your homework 32 for today. So, all my lights reset. Number 3. Number 1. Segment BE bisects angle DBA. That is given. This is a bisect, so I'm not going to just throw that angle, like 1 is congruent to angle 3, like down. I'm going to actually use my bisecting first. So BE bisects angle DBA. DBA is right here, okay? You could tell me that angle DBE and angle ABE are congruent, or because there's numerical values here, like there's numerical values here, you can just say that angle 2 and angle 3 are congruent because we have those numerical values in here. Otherwise, you're going to be crossing letters with some numbers. So if there are letters or numbers within your proof, you can state angle 2 is congruent to angle 3 and use that instead of the 3 letters, which is nice because some of you guys like to do that anyways. So this would be definition of angle bisector. All right, and then also 3 line, I have angle 1 is congruent to angle 3, and that's a given. These 3 steps can go in any order that you want as long as BE bisects DBA, angle DBA before the 2 and 3. So I'm going to use some colors. I'm going to use 2, 1, 3. And remember, these are the lines that we're trying to get to be congruent. So hear me out for a second. We want to prove that this line and this line are parallel. So hypothetically, this is what I want to get to. I need this line and this line parallel, which means I need an angle. This is what I want to prove. Okay, this is what I'm proving. That is really bad arrow. I need to prove that this is parallel to this. That pencil marking is not saying that they're proven yet. So, if 1 is congruent to 3, so 1 and 3 are congruent, and now 2 and 3 are congruent, I need to get 2 and 1 to be congruent because they are the only angles that exist on this transversal. I could do something with 4 and over here, but I don't have anything that I could use with it, and I don't have any consecutive interior to do supplementary, so really, like, I need to get 2 and 1 to be congruent because they are the only angles, once again, on that transversal of the 2 lines that I need to prove. So 2 congruent to 3, 1 congruent to 3. Angle 1 is congruent to angle 2. That's the transitive property. And then, like I said, what type of angles are 1 and 2? 1 and 2 are alternate interior angles. They are on the transversal that goes through these 2 parallel lines, which means I can state that segment BE, sorry, they are line segments, not lines, to segment CD, and they are alternate interior angles. But once again, this is not theorem. This is going to be converse because I'm proving these lines parallel. All right. The rest of these I'm going to leave until tomorrow, and we will do those ones in class.